Hello guys, this is Dr. Possibility from Excel Academy. Please make sure that you subscribe to our YouTube channel and make sure that you register with Excel Academy. And kindly note that Excel Academy is currently offering both online and physical classes. So in today's class, I just have a simple task which is to explain on the total blood volume. I'm pretty sure we are all aware of what I explained in the previous class where I talked of the body fluids, in which I had to discuss the extracellular fluid, the intracellular fluid, and also other components of the body fluids. So this is just a continuation of what I taught in the previous class. So the first part which I'm going to explain is the total blood volume. So what is this total blood volume? What is its definition? So the response to that question is, when we talk of the total blood volume, we're simply talking about the addition of plasma and the cellular component of blood. So when we talk of the cellular component of blood, in most cases we simply talk about the red blood cells. But the fact is that it's not only the red blood cells which make up the cellular component of blood. Instead, we also have other cells such as the white blood cells. Now, when we talk of blood, blood is considered as a separate fluid compartment. Blood is considered as a separate fluid compartment. So when you relate this class to the previous class, you are going to find that in the previous class we had to discuss about the plasma, we had to discuss about the interstitial fluid, and also the intracellular fluid. So this blood we are talking about, it is separated, it is independent from other fluids. Remember that the body consists of different fluids and blood is just considered to be its own. Now, what is blood considered as a separate fluid? So you're going to discover that blood, it makes up the circulatory system, which is responsible for the transportation of nutrients, which is also responsible for the transportation of oxygen, carbon dioxide, and other different substances, which can also include the hormones. So this is why it is important for us to know what blood is all about, what is found in blood, and what it is simply made up of. So now, why should we understand and why should we learn the total blood volume? So it is important for us to know the blood volume, reason being that it helps us to control some cardiovascular dynamics. So there are so many cardiovascular dynamics we can talk about. So when we know about blood, the volume of blood, we are able to understand so many things that are related to 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 circulatory system. You can talk about stroke, you can talk about heart attacks, you can talk about so many things that are related to the circulatory system. So it is very important for a medical student, for or any health related program, for that student to be able to understand the blood volume, its importance, of which we have said that the major importance of blood volume is help us to control the cardiovascular dynamics. Okay, now what is all about this blood volume? How much blood is in the body? Okay, so it's very important once again for us to know how much blood is in the body. It's not just about knowing the components of blood. We can talk of the red blood cells, we can talk of the plasma, we can talk about so many things. But it's very important to know what is the total amount of blood in the human body. So remember, last time we used a 70 kg young man. Even this time around, we'll be using a 70 kg young man. So a 70 kg young man is said to have about 5 liters of blood. So you as a medical doctor, you as a health personnel, you need to understand how much blood is someone supposed to have. So it's not all about knowing the component of blood. It is also important for you as a medical personnel to understand that how much blood does a normal human being have, of which a human being has about 5 liters of blood. Okay, now we said that blood consists of what we are calling the plasma, and blood, it consists of what we are calling the cellular component. So amongst these two things which I have mentioned, you need to understand that about 60% of blood is made up of plasma. About 60% of blood is made up of plasma, and the 40% it's also made up of the red blood cells. So make sure that you know these figures, make sure that you understand how much red blood cells are in the blood and how much plasma is in the blood. So from this, you can understand that, we people are different. How me, myself, as possibility, how I am, it's totally different from how someone else is. So this volume or this percentage, that varies depending on the gender. So you find that there is a significant difference between a female and a male. So you need to understand that male, they tend to have more blood volume than female, and these constituencies or these components such as plasma and red blood cells, they also follow suit in terms of that. This also depend on the weights, the weight of someone, the mass of someone, and many other condition. We can talk of health conditions, you can talk of so many things. Okay, now we are saying that blood is made up of 60% of plasma, and it is also made up of 40% of red blood cells. Okay, now let's quickly discuss something that is very important, which is important when you are analyzing the blood of a human being. So the best term that we can discuss at this moment is hematocrit. So the question is, what is hematocrit? So just from the word hemato, you can simply say that this is simply talking about what? Red blood cells. Okay, so hematocrit is just a ratio which is trying to show the ratio between the red blood cells and the total blood volume. So hematocrit, this hematocrit here, it just tries to show the ratio between the red blood cells and the total blood volume. In short, it just tries to explain what amount of red blood cells is in the total blood volume. So we talked that the red blood cells, they made up of 40% of the total blood volume. So this hematocrit, it just tries to explain how much red blood cells are in the blood of a human being. And in this case, we are simply talking about a 70 kg young male person. So When you talk of hematocrit, like I've said, it's just showing the ratio between the red blood cells and the total blood volume. So why is this important for an health student to know these things? This is important for you to understand diseases or conditions such as anemia, conditions such as polycythemia. So you find that when you talk of anemia, this is the condition whereby a human being has less red blood cells. So we have a lot of people who are suffering from anemia. In most cases, you discover that these conditions, they are genetically inherited. So anemia is one of the condition which you can use to apply when you are discussing this part of our subject, which is hematocrit. So when you are able to know the ratio between the red blood cells and the ratio between the red blood cells and the total blood volume, this will help you to analyze some health conditions such as anemia and such as polycythemia. So let me quickly give a picture of what we are supposed to know. So after centrifugation, after you centrifuge the blood, this is the normal ratio which is supposed to be shown in your test tube. So you find that the upper part has to be made up of plasma. So this is plasma in the normal blood. So plasma, as I said, it is made up of different things. You can talk of hormones, you can talk of glucose, you can talk of proteins, you can also talk about water. Okay, so this plasma in a normal human being, it forms about 60% like we stated. Then there is this small portion which is made up of leukocyte and platelets. So when you talk of platelets, these they play a major role in blood clotting. Okay, so platelets, let's say you have a cut, maybe you are playing with a knife and then you accidentally cut yourself. So these platelets, they'll play a major role in blood clotting to avoid excess loss of blood. And then leukocytes, when we talk of the skin pathologically, you find that the skin, it forms the first defense. That you can understand it when you talk of immunology. It's part of the innate system which is protecting you from any bacteria. So once you cut yourself, you need to understand that you have exposed your inner side of the skin to some pathogens. So during that process, this leukocyte will play a role in preventing any harmful or strange foreign material that might enter your body. Okay, not only that, this leukocyte, they play in short in the immune system. There are different types of cells. When you talk of the leukocyte, we can talk of the neutrophils, the basophils, the eosinophils. All those cells, they are making up the leukocyte. Okay, then when you talk of the major interest of ours, which is the hematocrit. So the hematocrit, in this case, it is just made up of red blood cells. Okay, so if you compare this beaker and that beaker and that beaker, so you find that in case someone is suffering from anemia, okay, so anemia is a condition whereby there is less amount of red blood cells. Okay, there is less amount of red blood cells in the blood. So when someone has less red blood cells, we need to understand that there will be little transportation of oxygen to vital organs. Okay, so this is why you find that people with anemia, they really find it hard for them to cope up with some heavy works. Why? Because there is less oxygen which is taken to the vital organs, to the muscles, to the to the heart itself, to the brain, and to so many organs of the body. Okay, so why? There is less blood cells. So when you talk of anemia, anemia is a condition in which a human being has less red blood cells in the blood. Okay, then polycythemia, this is where by now the body is producing excess amount of red blood cells. So some of you may say, no, this condition is okay if someone is having excess amount of red blood cells in the body. Remember that any anomalies, any abnormalities in the human body, the body always responds. Any excess, anything that is not according to what is supposed to be done, you need to make sure that the body will respond to that. So now, this process, we can say it is not 100% accurate when we are trying to measure the amount of hematocrit. It is not 100% 100% accurate. So it is said to be 96% efficient, and when you talk of 96% efficient, that means that it is not 100% accurate. Why is it not 100% accurate? So the answer is simply that it is very impossible for one to pack the red blood cells together. It is very impossible to make these things, these red blood cells to be packed together. All right. So one other thing you need to understand is that the amount of red blood cells, it is totally different from the woman and from the man. So you understand that men tend to have more hematocrit value than women. Men have a lot of red blood cells as compared to women. So normally you find that the hematocrit value, so the hematocrit value, we are simply talking about the ratio between the red blood cells and the total blood volume. Okay, so in men, you find that in men the value is 0.4. In men, the value is 0.4, whereas in female, it is 0.36. Quite all right, there is no much variation, as you can see from there. So this is why I said in the previous slide, I stated that there is the hematocrit value, the total blood volume, and other stuffs we are discussing. They depend on the weight, they depend on the gender, and they also depend on various factors. Okay, now this also hematocrit value, like I've said, it can be affected by factors such as anemia and factors such as polycythemia. So anemia, like I said, this is the condition whereby there is less amount of red blood cells in the total blood volume. And then when you talk of polycythemia, this is the condition whereby you observe a high amount of red blood cells in the normal human being. Now, we have discussed about the hematocrit value. Please make sure that you understand these values. Make sure that you know what factors makes a difference in terms of hematocrit value. And make sure that you know the definition of hematocrit value, which is just the ratio between the red blood cells and the total blood volume. All right, and then when you talk of total blood volume, we are talking about the cellular part and the plasma part. The plasma part has things like water, it has things like proteins, it has things like glucose, it has things like hormones and other stuffs. Now let's quickly look at factors that affect the total body water. Okay, so in the previous class, I explained that the amount of water, it varies from one region of the body to another. For example, I said that in the teeth there is 8% of water. Your teeth has 8% of water, whereas the brain, it shows the highest amount of water, which is 85% of it. So the amount of water in the body varies. So this same applies that the amount of water in human beings also varies from one person to another. The amount of water that I have is totally different from amount of water that another person has, who is maybe aged, maybe a baby, or maybe any other substance. So I'm going to give you individuals whom we are going to check up. So I have a baby with me. I also have this beautiful lady there. I also have myself there, and I also have one of the prominent Zambian politician there. Excuse, and I also have our grandmother there. So the question is, amongst these five people, who do you think has more water in the body? Amongst these people, who do you think has more water in the body? So the amount of water in the body of a human being varies according to the age, varies according to the diet, varies according to the body size. For example, when we talk of all these five people, this baby has a lot of water in it. This baby has a lot of water in it. So if you even check up the texture of the child, the texture of the texture of the skin of a child, and the texture of the skin of this old woman here, you find that there is a very big difference. So if you look at this old lady here, our grandmother here, if you look at the texture of the skin, it's simply telling you that this person has less total body water as compared to this child who is at this point. So now, what are the factors that affects the total blood, the total water? So the total body water depends on the age. For example, in this case, we can talk of the infant. So this baby is simply representing the infant. So when you talk of the infants have about 66 to 63 to 80% of body water. So children have a lot of water in their body as compared to us adults. Then when you talk of the male adult, for example, in my case here, I'm composed of approximately 60% of my mass is made up of water. Then the female adult, it is from 40% to 50%. Within that range, that's where you can find a female adult having their total body water. So if you look at the male and the female, you find that this male here is having 60%, but when you talk of this lady here is also having somewhere 40 to 50%. Okay. Then the other thing we can consider is the old age, which is for approximately 45%. So like I said, if you look at the skin texture of this old woman here, you find that it is even showing that this woman has less body water as compared to the infant. Now, let's say I pick this big man here and I also pick myself there. So myself, I have a lot of body water, total body waters as compared to the big man here. Why? Because of the fats. So the difference in fats, okay, the difference in lipids, the difference in adipose tissue. So fats can also be said to be adipose tissues. Fats can also be said to be lipids. So the difference in lipids, they also contributes to the difference in terms of total body water. So in this case, I have more total body water as compared to the big man here. Yeah. So other health conditions such as obesity, they also contribute to the amount of water in the human being. Now, we have completely discussed different fluids that are found in the body. We have completely explained the different types of fluid, like we have the extracellular fluid, we have the intracellular fluid. The extracellular fluid is divided into two, which is interstitial and also the plasma. Then we have also talked about blood, which is made up of the cellular component and the plasma component. Then when you talk of plasma, we have explained that plasma is made up of hormones, it's composed of water, it's composed of glucose, and so many things we can explain. Then the cellular component we can talk of, we have the leukocytes, which is making the immune system of a human being. We also have the particles such as the platelets, which are playing a role in blood clotting, and we can also talk about the red blood cells, which are forming 40% of the blood volume. And we said the red blood cells, there is a big difference in men and women. For example, in a normal young man, it is 0.4. That is the hematocrit value, and in female it is 0.36, which is the hematocrit value. And at this point, I have explained the factors that affect the total blood volume. One, it depends on the what? On the body fats. So the body fats, these are adipose tissues. These can be also be said to be lipids. And then we have also talked of the age. So the age also matters, the gender also matters, and also some healthy conditions. So in this case, I've mentioned four factors that affect the total body water. One, we have talked of the body fats, we have talked of the age, we have talked of the health conditions, and we have also talked about the the what? The gender. All right. So with that being said, how can we measure the body fluids? All these fluids we have measured, we have talked about. What are the what are the ways can we use to measure this body fluid? So in most cases, we use dyes in order for us to measure these fluids. So these dyes, we don't just pick, you pick this dye, that dye, and that dye, then it works out. No, there are some properties that they are supposed to show for them to to be said as a dye to use. For example, I can't use a dye that's going to kill a human being. In short, I can't use a poisonous dye to measure someone's body water, someone's amount of red blood cells. I can't use that. So let's quickly look at the properties of these dyes. So the first property is that it must mix evenly throughout the compartment of the interest. So this means that if we are trying to measure the amount of red blood cells, it has to completely it has to completely mix with the red blood cells. Nothing should remain. So it has to make sure that it completely mix with the red blood cells. If we are trying to measure the plasma, it has to make sure that it's completely mix with the plasma part. The other thing is that it should be non-toxic. Okay, so when we talk of toxic, we are talking about poisonous. So it's not supposed to be poisonous. You know, the goal is to save the lives of people. The goal is to save the life of the patient. So even when we are trying to measure the body fluid, the amount of whatever fluid we are interested in, we need to make sure that the dye we are using is not toxic, it's not poisonous. The other thing we need to understand is that this dye is not supposed to affect the normal physiological activities of the body. Many are the times we have observed someone inject someone with a wrong medicine. Like, this is a trend in most of the developing countries. You find that someone will go at the market and find someone who is simply impersonating to be a medical doctor. Then they give them the injection. At the end of the day, they lose their hand, they lose their legs, all because they were injected with a wrong substance, and that wrong substance is has to affect the physiological activities of the body. So when we are measuring the body fluid, any body fluid of interest, we need to make sure that the dye we are using is not affecting the normal physiological activities, such as the breathing rate, such as the heartbeat, such as the blood flow, any other thing. Then another thing is it's not supposed to affect the distribution of water, which is just H2O, or any other substance in the body. It's not supposed to affect the distribution of oxygen in the body. It's not supposed to affect the distribution of glucose in the body. Not any part of the substances in the body is supposed to be affected when you use such a dye. Then the other thing is it has to be, it's either it must be unchanged during the experiment, or if it changes, the amount change must be known. So in healthy, it's very important to be very accurate. If there is any change of anything, it has to be known by the health personnel. So when you are using a dye, that dye, it's either it remains unchanged, meaning it is constant. If the amount was 30 moles, 30 millimoles, or whatever amount it is, it has to remain like that without changing. Then the other thing that has to be taken note, that in a case a change is seen, the medical personnel should be able to identify the amount of change that has taken place. So why are we interested in knowing the amount of change? This is very important for calculations. Remember, when we are measuring something, it's all about knowing the calculations. So if there is any change in the dye or in whatever we are using to measure a particular fluid in the body, it has to make sure that the amount is known in a case there is any change. Then, now there is a change there. So in a case there is a change, the material should be relatively easy to measure. It has to be measured easily. Okay, no need of struggling for you to measure the amount of change which has taken place. So these are the 6 properties of the dye that any dye is supposed to have for it to qualify to be used for measurement of body fluid, any body fluid. So when you're making your research, make sure that whatever dye you're using is able to obey those rules. Now, let's look at some of the methods which can be used to measure this body fluid. So the first method we can look at is the dilution principle. So when you talk of the dilution principle, this principle, it relies on the mass conservation. Remember, when you talk of mass, mass can simply be said to be, when you talk of the law of conservation of mass, it states that mass cannot be created or destroyed. It is a scalar quantity. It doesn't depend on a change in direction. So it's very important to take note that this property or this principle of mass, it helps us to measure the amount of fluid in the body. Okay, why? Because mass cannot be created, mass cannot also be destroyed. So this helps us also to come up with a theory whereby concentration of a given solution or the first solution and the volume times the volume should be equal to that. So these are easy measurements which you can simply use. So from there you can see this is the mass, there is the concentration, and that is the volume. So dilution principle, it is trying to use the mass, it is trying to use the concentration, it is also trying to use the the volume. So let's quickly look at this diagram of ours. So as you can see there, you can look at this syringe to be containing an indicator. So this indicator, it is already having the mass, which is equal to volume times concentration. Mass is equal to volume times concentration. So this indicator, you can mark it as the indicator A. So this can be said to be indicator A. So this indicator A, automatically we know that it is made up of the mass there, it is, and this mass is showing volume A, which is the volume of this indicator, times the concentration. So when this indicator is pumped into this solution, you find that this should be able to give us the value for that. Okay, so that's how easily this can be calculated. So in order for us to calculate there, we just have to relate the value for the value of the total there and also the initial, because we know that the initial has to be known, and then you use that simple formula over there. You're going to understand more when I explain it. So the other way we can use is the indirect method, which is also the law of mass. Now this one is a bit more indirect. That one was direct, but this one is indirect. So when you talk of the indirect, this is based on the concentration in a well-known mixed substance that distributes itself only in the compartment of interest. So let's quickly look at this. So when you look at this, let's say I have three compartments. Let's say I have my compartment there, and this compartment is having um, amount of fluids that we are interested in. So in this case, we have amount of dye, which can be said to be A, and then we also have the compartment, and this compartment is having a certain volume and also are having the concentration. And then there we have the amount of dye loss from the compartment. So after you add the dye, so when this amount of dye is added to this compartment, we also need to consider the amount of dye which has been um, which has been added there. So we have the added amount of dye and also the amount of dye which has been lost. So what can we use this for? So in order for us to measure the volume of this compartment, our major interest is the volume of the compartment. Remember, we are trying to find the volume of a given fluid. So let's say if this is having water, it's having blood, you put the amount of dye there, and this amount of dye, you need to take note of the dye which has been lost there. Okay, so in order for you to find the volume of this, the first thing you need to look at is what amount of dye remains. The first thing you need to consider is what amount of dye remained. In this case, for you to find the amount of dye which has remained, you just have to subtract this and that. Okay, so let's say this was, let's say 4 mils, and then this one which has been lost, it is 3 mils. So you just say 4 minus 3, which is equal to 1. And then remember that the concentration is well known. The concentration has to be well known. So in that case, for you to find the volume, you just say compartment volume is equal to A minus E, which is the amount of dye added minus the amount of dye which has been lost, then over concentration. All right, I'm pretty sure we can now look at an example or application of what I've just given. So let me quickly look at my example. So in this example, it is saying 150 milligrams of sucrose, 150 milligrams of sucrose is injected into a 70 kg man. Okay, it is injected into a 70 kg man. So this has no interest, has no role to play in our calculation. Then the plasma sucrose level after mixing is that. Okay, so this is the concentration of the mixture, the compartment. Let me quickly go back there. So that amount which has been stated, 0.01 milligrams per mil, it is the amount which has been found. It is the concentration which has been found. And then the injected amount of sucrose which was there, it is 150. And then we also need to understand that 10 grams of sucrose, 10 milligrams of sucrose were lost in the process. So in order for us to find the volume for that question, we'll just use that formula there, whereby we say 150 milligrams minus 10 milligrams over that concentration. So let's quickly go back to our question, like I've said. So we are going to use the formula there because we have been asked to find the volume of sucrose. Calculate the volume of distribution of sucrose. So you're just going to say 150 minus 10 milligrams over 0.01 milligrams per millimole. And this will give us our answer, which is 14,000 mils. Okay, so this is how easy what I've explained is applied. Okay, so let's quickly go on and look at some of the indicators which are used to measure the plasma volume. Okay, so let's quickly look at that. Indicators used for measuring plasma volume, extracellular fluid volume, and total body water. So take note of what we are trying to look at: the measuring plasma volume, which is forming part of intracellular fluid, and we can also talk of extracellular fluid, and we can also talk of the total body water. All right, so what's the criteria? What are some of the indicators used? So the first one, it is plasma, which is forming part of the extracellular fluid. So the first one, it is plasma. So this plasma, the criteria should be that the substance should not cross the capillary. So this is about the blood vessels. We have the arteries, the veins, and also the capillaries, which tend to be the smallest. So for you to measure the plasma volume, for us to measure the plasma volume, we need to make sure that the substance which is being used cannot cross the capillaries. Okay, now examples of these indicators can be Evans-Blue dye. You can talk of the radiohydrogenated fibrinogen, radiohydrogenated, oh, my pronunciation there, albumin. Those three as the three examples of indicators that can be used. Then when you talk of the extracellular volume, so the extracellular volume, remember the plasma volume has been measured. You can measure it using these indicators here. Make sure that you know them. Then for us to know the extracellular fluid, we need to make sure that the substance should cross the capillary but not cross the cell membrane. So what does that mean? This is the capillary wall. So for us to measure the plasma, the substance is not supposed to cross this capillary. Now, for us to measure the extracellular fluid, this dye is not supposed to pass through the cell membrane, but it's supposed to pass through the capillary. So examples are inulin, you have mannitol, you also have sodium chloride. So these three, they have to make sure that they are in the isotonic solution of sucrose. Then total body water, the substance should distribute evenly in intracellular fluid and extracellular fluid. That means that the substance should be able to cross the membrane there. Okay, so it has to be able to be distributed here, to be distributed there, and to be distributed there. All right, so what can you use? You can use heavy water, tritiated water, aminopyrine and pyrene. Those are the dyes that you can simply use. Okay, now let's look at the calculations of ICF, which is the intracellular fluid, and the interstitial fluid. Okay, so in this case we have just shown how you can measure the plasma, how you can measure the extracellular fluid, how you can measure the total body water, but we haven't talked about the interstitial fluid. We haven't talked about the 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 intracellular fluid. The only thing we have focused on is how you can measure plasma, how you can measure total body water, and how you can measure this extracellular fluid. So if at all we know that, we need to take note that intracellular fluid and the interstitial fluid, these two can only be calculated. These two can only be calculated. They cannot be measured. There is no dye which can be used to measure the intracellular fluid, and there is no dye which can be used to measure the interstitial fluid. Okay, so meaning we can only calculate these two substances. So since we know the total body water and we know the extracellular volume from the measurement I've shown in the previous slide, we are able to know the extracellular volume. We are also able to know the total body water. Remember, the extracellular fluid was the dye was supposed to cross the capillary, meaning it was able to measure everything here. Okay, now when you talk of the total body water, it was measuring the whole amount of water which was here. And so meaning, since we have the amount of water, we also have the extracellular fluid. For us to find the interstitial fluid, the only way we can measure it is by saying interstitial fluid, intracellular fluid. Intracellular fluid is equal to total body water minus extracellular fluid, okay, volume. So you just have to subtract the amount of water which you measured minus the extracellular fluid. Okay, then when you talk of the interstitial fluids, since we have the plasma there, so the only way you can measure the interstitial fluid volume is by subtracting the plasma volume from the extracellular fluid volume. So that's how easy you can subtract. So intracellular fluid volume is equal to total body water minus extracellular fluid. Then interstitial fluid volume is equal to extracellular fluid volume minus plasma volume. All right. Now, how can we calculate the blood volume? How can we calculate the blood volume? Remember, the blood, when we talked of the blood, we said that the blood is made up of plasma and is also made up of the red blood cells. Okay, so and then when you talk of the hematocrit, hematocrit was just simply giving us the ratio. Okay, the hematocrit value, in this case they are the hematocrit value. So the hematocrit value is giving us the ratio. Okay, it's giving us the ratio between the red blood cells and the total blood volume. So that's the ratio. Then when you talk of plasma, automatically we know what plasma is. So how can we find the total blood volume? So you can easily find the total blood volume by saying plasma times 100 over 100 minus hematocrit, meaning 100 minus the amount of red blood cells in the body. So let me quickly give an example. So in this example, we are saying the hematocrit is 38. The hematocrit is 38, meaning the amount of red blood cells in this component is 38, and the plasma volume is 350 mils. Calculate the total blood volume. So in this case, what we are going to do, we are just going to say 3,500 times, we say 100 over, and then we can say 100 minus 38. 100 minus 38. So this will simply give us a value which is 35, and then 4 zeros there, over, you can say 100 minus 38 is simply going to give us what? 62. Yeah, it's going to give us 62. So when this is worked on, we are simply going to have a value of 5645 mils. Okay, sorry for my pen is not writing properly. All right, so that's the value there, which I've simply found when I do my calculations. Okay, now when we talk of the red blood cells, the red blood cell volume can be calculated by subtracting the plasma volume from the total blood volume. All right, I think that's all for this example. All right, so let's look at determining body fats by using bioelectrical impedance technique. So this is just a technique that is used. Okay, so fluids, we have measured water, we can use dye. Plasma, we can use dye. Extracellular fluid, we can use dye. Intracellular fluid, we can use the formula whereby intracellular fluid volume is equal to total body water minus extracellular fluid. Okay, so we have discussed all that in the previous slide. So another thing that we can use is another body fluid, that another component which we are supposed to focus on is the body fat. Remember, when I gave examples of those three people, you discover that those five people had a difference in total body water because of the component of fats, because of age, and so many factors. So there are three principles that we are supposed to follow when we try to consider measuring the body fluid, the body fats. So the first principle is that we need to consider the body fluids conduct electricity well. The body fluids conduct electricity well. That's the first principle we need to understand. Then the next principle we need to understand is that fat is anhydrous and therefore is a poor conductor of electricity. So this is more like forming one principle which has just been separated into two. The first principle is that body fluids conduct electricity well. But when you consider fats, they do not conduct electricity well. So such principle can help you to measure the body fats. Then the resistance to flow of a small current between points on the body is proportional to fat mass. So these are the three important principles that we are supposed to know when we are determining the body fat. Okay, so with that being said, let's quickly look at the next component, which is the lean body mass. So there is also the lean body mass. So the question is, what is the lean body mass? Okay, so the lean body mass is fat-free mass. Remember in the previous slide, I was trying to explain on how you can calculate the 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 body mass, the principles, the three principles we use to measure the body mass. Okay, now when you talk of the lean body mass, we are talking about the mass of the human body without the fats. The mass of the human body without fats. Okay. The mass of the human body without fats. So, how can you calculate this? So, you need to understand that the total body mass is equal to fat mass plus fat-free mass. So the fat-free mass is the lean body mass. This fat-free mass, it is the lean body mass. The total body mass, my mass, is equal to the mass of the fats in my body plus that mass of other substances without the fats. Okay, like in this case, this dude, so this guy, when you talk of these things, the belly, the laps, the bums there, all these things, they are made up of fats. So when you remove the fats there, you now have the muscles, you have the bones, those things which have remained, they are the fat-free mass. But when you talk of the fat mass, it is the mass of fats, of course. So the total body mass is just simply equal to the fat mass plus the fat-free mass. All right. So what are some of the facts that we need to look at when we are talking about that? The first facts, like I said, is that fat is relatively anhydrous, meaning um, it does not conduct electricity. Then it doesn't conduct electricity, and it doesn't relatively mix with water. Those are the three components. Then the water content of lean body mass is constant. Okay, so this is approximately 70 mils 70 mils per 100 grams. So this lean body mass, the content, okay, the content of the what the water content of lean body mass is constant. The free the fat-free mass has a constant amount of water. The fat-free mass, the lean body mass has what? Has a constant amount of water, which is somewhere 0.7 mils per gram. 0.7 mils per gram. That's the amount. So H2O content of lean body mass is 70 mils per 100 grams, which is just 0.7 mils per gram, like I've stated. So this amount is for water in the fat-free mass of the body. This is for the fat. This other part is the fat-free mass. So the fat-free mass has a constant amount of water, which is 0.7 mils per gram. Okay. Now, let me give an example of a calculation which is involving what we have just said. So, Mr. Luhanga is an adult male weighing 70 kg. So, this is the amount, the mass of the person, okay, 70 kg. His total body water was measured and found to be 42 liters. What is the lean body mass and what is his fat mass? So this man is having the total body water of 42 liters. The total body water of Mr. Luhanga, who has a mass of 70 kg, the total body water of this man is 42 liters. Now, for us to solve this, we can collect the data of which total body water is equal to 42 liters. We are going to make an assumption. So let's say, let's assume that all this water is in the lean body mass. So all this water, this 42 liters, is in the lean body mass, and fat is water free. Okay, so those are the two assumptions that we are going to take note of. Now, we know that the content of water in the lean body mass is 0.7 liters per kg. Okay, 0.7 liters per kg. That's the amount of the lean body water. So this guy 0.7 liters and 1 kg. Some of you may try to wonder how come this is the same as 0.7 mil per gram. So the aspect is that this milliliter, when changing it to liters, it is 1000. Gram, when changing it to kilogram, it is still 1000. So the 1000, they are going to cancel each other. So it's just one and the same. So for us to find the total body weight, we're going to use the formula whereby we say 42 liters over 0.7 liter per kg. 0.7 liter per kg. Okay. Remember, 0.7 mil per gram has changed to 0.7 liter per kg because both mil to liter it is 1000 and also gram to kg it is simply 1000. So for us to find the total body weight of this the total body weight, the total body water, which is 42 liters, and for us to find the lean body mass, which we have been asked, for us to find it, we are going to use the amount of water which is there, and then we use the ratio, and this will simply give you the 60 kg. So since we have found the fat-free mass, which is 60 kg, since we have found the fat-free mass, which is 60 kg, so for us to find the amount of fat in the body, you can just say 70 minus 60, which is giving you the 10 kg. So you find that when you take someone who is a little bit fat, let's say that person is 10 years and that person is fat. So when you get that person, you take them to the scale. At the same time, you take a slim person who is 10 years. So this person is 10 years, the other person is 10 years. When you take them to the clinic, they are going to have different weights. So this person is fat there, and then this other one is a little bit slim. Okay, so if these two guys were both at 10 years, if these two guys were taken to the weight, to the scale, you find that this one will be a little bit heavier than the other one. Why? Because this guy has a lot of fats as compared to that one. Okay, so this is why it's very important for you to understand these aspects. So I'm pretty sure we can go on and talk about many examples about the total body water and other stuffs. So these are just some of the concepts that I had for you in today's class. I'm sure it's a very long class, having 1 hour 10 minutes. So in the meantime, ladies and gentlemen, I'm going to end here, and I wish you a blessed evening. Make sure that you subscribe to our YouTube channel, and make sure that you register with Excel Academy.